Welcome Math 30-2. So this is our first lesson of set theory. We actually started this lesson before the big break that we have here. So we're just going to go through the first lesson again. So if you have these notes already and you understood it just fine, let's move on to the next 2 or 3 videos here. Just wanted to mention as we go through these videos, at any point just pause, try some of the questions out yourself. At the end of each of these little videos, I'll have an assignment or activity or something for you to do to try them on your own. If you have any questions on anything that you see in this video or any of the assignments that we do, just give me a call on the Google Hangouts and I can answer those questions as we go. Just remember our Google Hangouts are mainly in the morning. In the afternoon from 1 to 2-ish. You'll see that on the Google Classroom there. And just follow along with the little guide that I give you. Make sure that you're following along the lessons. Make sure you're keeping up a track. Which I'm going to try to limit this to what the Alberta government says, about 3 hours a week. So it shouldn't be too hard, shouldn't be too difficult. Just keep up. Do the assignments and the possible quizzes at the end of each week, and we'll get through this just fine. Okay. So let's talk about Venn diagram set theory. So if you remember from what we did before, a Venn diagram, also sometimes called a Euler diagram, is, let me just get this in the right mode here. There we go. Where's my little picture here? How do we get, Venn diagram, or sometimes called an Euler diagram, is just a diagram that represents how sets or different types of things interact with each other. Such in this case, we're looking at some of these fruits and veggies, and we have this goat kind of sitting here. We want to know, how do they interact with each other? Can we categorize them as different sets? So I'm looking through my list here. I'm thinking, what do they have in common? What do they not have in common? Most of them are fruits and most of them are veggies. So that means probably those are the main sets. We have this goat here. We'll talk about this goat at a later time. Where does he belong in these 2 sets, or if he does belong in these 2 sets? So here's a Venn diagram. They only given us 2 circles, so let's just say that these are the 2 sets that we have. And let's just call this first set the fruit set. And let's call this one the veggie set. Okay? So we're going to put these fruits and veggies into these 2 circles here. Things that don't belong in these 2 circles, we're going to fit out here into this outside set. This is the whole box. Everything inside this box, we call this the universal set. So that includes the fruits, veggies, and everything that's in this box. So anything that's in this box, these 2 circles included, we just call that the universal set. So the first thing I want to look at is say, where does this goat belong in these 2 sets? Well, it doesn't belong in these 2 sets. And because it doesn't belong in these 2 sets, we sit him out here, out of his own on the outside of these 2 circles, because he's neither a fruit or a veggie. Then we go through and you start putting the things into each of these little circles. Just make things a little bit easier. Let's just label these with letters, so I don't have to write the whole word out later on. And zucchini, so that's good. I just wrote the whole goat out, so we'll just leave that there. So we go through what's a cucumber. Okay, most people accept cucumbers to be veggies, so you can put that in the veggie spot. But also a cucumber, since most people accept to be a veggie, people say it is a veggie, but technically because of the seeds inside it, it's actually a fruit. So because of the fruit, and most people accept it to be a veggie, maybe you could put it in this spot that inside between the 2. Same thing with tomato. Most people say it's a fruit, a veggie, but technically it's a fruit because of those seeds. A banana was never considered a veggie, so we're going to put him in this circle here, but he's not going to be in this intersection point here, where he's both a fruit and a veggie at the same time. That's where cucumbers and tomatoes are so far. Lettuce doesn't have the seeds, just the leafy part of a plant, so that's completely a veggie. So we're not going to put him in the intersection point because he's not going to be in the fruit circle as well. An apple, always considered a fruit. A pear, always considered fruit. And a zucchini, technically because of the seeds inside it, are also considered a fruit and a veggie at the same time. Now, lots of people can draw these a little bit differently. Like you could probably put the cucumber and zucchini just in the veggie spot. but they follow the same rules as the tomato. The tomato is both a fruit and a veggie, depending on how you want to look at that and how you classify it. So that's essentially what a Venn diagram is. You're just classifying, you're putting objects inside two different sets, and then you're looking at any relationships between the two, or do any numbers or do any elements. These are all called elements of the sets. Do they can it be categorized as two different things at the same time? Or do some things just not belong and they just sit on the outside? Now, all of this here is our universal set. Okay? A few things that you might see, and you can see that this will be on the formula sheet that we give you. And if you haven't done so, you might as well download it. It'll just be on Google Classroom there. So a few things that you may want to know what a complement is. A complement just stands for not. It is not that. So if I go back up here, I could say in this question up here, if I can actually scroll up here, what's not a veggie is going to be a goat, a banana, an apple, and a pear. All right, so that's everything that's outside this circle. So that's the complement of a veggie. An empty set is a set that just doesn't have anything in it. So sometimes when you write those as sets, you just write them as curly brackets with nothing in it, and that just represents this. It's not a zero with a line through it. It's actually a very, very perfectly designed circle with a line through it. It's just that has nothing. Up here we have no empty sets. Everything, each one of these circles has something in it. The intersection symbol is this kind of upside down N looking thing. It's not an N. It's kind of a U that's turned upside down. That's just a different mathematical symbol, but it represents, when it comes to two sets like the one we have above it, it represents this area that's in between the two. It's where they intersect each other. What do they have in common between these two sets? Okay. Subset would be if something is inside another set. So if I were to say draw another set like this, and then I would draw another set here, this set, so these are two different sets. You got a circle on the outside and a circle on the inside. This set that's on the inside is a subset. It is completely inside the other. These two circles above here, they're not subsets because there's some things that are not in the other circle. If one circle is completely engulfed within the other one, we call that a subset. And a union, say of two circles, a union is just what is everything in those two sets, including what's in common, including what they don't have in common, but that's just the union. So everything that's in the two circles at the same time. Just back to my draw there. There we go. So here we have a universal, or we have a couple of sets here. We have a big set of all the numbers between 1 and 20. Okay? Some of these numbers are even. Some of these numbers are prime. That's what we're looking at. We're looking at two sets of even and prime. And some numbers are just not even or prime, so we kind of sit them on the outside over here. Okay? You can see, look at some common things that we have here. The set that this number 2 here is in both these sets at the same time. It is an even number. Remember, an even number is anything that's divisible by 2. And a prime number is anything that's divisible by 1 and itself. You know, that 1 is not a prime number because a 1 is divisible by 1 and 1. That doesn't really count. 2 is a prime number, but it's the only even prime number. You can say 3, 5, 11, 7. These are the other prime numbers. These are even numbers. You see 9 over here. It's not an even number. It's not a prime number because it's 3 and 3 can make 9, 3 times 3. The same thing with 15, like 3 times 5 can make 15, but they're also not even, so they kind of sit on the outside here. It doesn't matter where you draw them on the outside. You could have just drawn them all in this one little corner down here. That's fine. Okay. So I'm looking at these sets here. If I wanted to talk about these sets, this is how I would write them out. So like the universal set. The universal set is this big box I was saying before. It's everything that's inside this box called the universal set. So the universal set that we know of is 1, 2, 3, 4, dot, 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 dot. I'm not going to write them all out, but they would continue on till you have all the numbers up to 20. Okay, so that's my universal set. It's all the numbers from 1 to 20. That's what it says at the very top there. So a subset is a set of numbers that belong to another set here. So in this case, we have a couple subsets here. Like this is my universal set. And you can see that the circle, the prime circle, is completely within that universal set. So I could say that the prime circle is a subset of the universal set. The universal set, let's just write the whole universal set. All right, it's a subset, and that's that kind of weird looking C. It's a very straight looking C there. I could also say that the even numbers are a subset of the universal numbers as well, or universal set. Because that circle there is completely within that box. Okay. The union between, let's say this is P stands for prime and E stands for even, the union between those two things would be everything that's in the E prime circle and everything in the even circle, including the 2, because that's in both circles. You wouldn't write it both times, but it wouldn't include everything that's outside here. I'm looking for just the stuff that's inside the circles here. Nothing to do with the universal set at this point. So there's no 1 here, so this set's going to start at 2. 3, 4, 5, 6, 7. There's going to be a lot here. 8. Nope, 9 is not one of those. Remember, that's on the outside there, so 9 and 15 don't belong. So if I were to write all this set up, the only numbers I won't have in it is 1, 9, and 15. All right, so if I keep on going, 10, 11, 12, 13, 14, 16, 17, 18, 19, oops, and 20. All right. The upside down U, that stands for the intersection. So this is the union. So it's a set of all the numbers between the 2, including what's in between the 2. So all the numbers in both those sets, or all the elements, just to say. The intersection, like I was saying, is this piece that's in between. So the union is this here. That's all of that. You can see that this circle here is a subset. If I were to look back here, that circle is completely within this box here. So both of these elements are subsets, or both these sets, sorry, are subsets of the universal numbers. The intersection, though, is that this little piece that's in between the 2. Right? So that would be this 2. The only number that belongs between the 2 is 2. Okay? They get a little bit harder as you go because you start adding in things like what is the complement of P? What is not P? So if you think about what a P is, and remember our P's are on the one left side. So this side over here is our P's. This side over here is our E's. So what is not P? Well, P is the circle. So not P is everything that's outside of this circle. So all of this stuff. So that's part of the evens. It doesn't include this part of the evens because that part is part of my prime numbers. So this 2 that's kind of sitting here is inside this little circle. So that 2 is a prime, so that's not going to be included in my set. So it's what's actually included in my set is everything that's not prime. So that's the even numbers, but not including 2, and 1, 9, and 15. So 2, 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, and 20. There you go. What is not even? So you think about this again, there's the 2 here. And even is on this side, so what's not even is everything that's just not in that circle. So all of these numbers are not even. So that would still include 1, because that's still in the universal set, but that's not in the circle. But now it will only include the prime numbers, 1, 15, and 9. So what were the prime numbers again? 3, 5. So you notice it didn't include 2 because 2 is inside the evens. So I'm looking for not evens. 7, 9, 11, 13, 15, 17, 19. I think that's all the numbers there. Okay. Now it's going to get a little bit trickier as we go because we're going to start adding in kind of intersections between certain things. I'm just going to kind of zoom in here a little bit for this next part so I can see these circles a little bit nicer. All right. So let's first of all figure out what we want here. We want the intersection between, so this symbol stands for the intersection again, between the primes and the not prime, or not evens, the prime and the not even. So what I'm going to do for this to kind of work out here, so I'm going to highlight certain pieces. So this is the primes, and I just want to see if this is going to give me a different color. No, that won't give me a different color. Maybe this aqua green. Yeah, okay, this one. Okay. Let me just erase some of that. Oh, erase the one I didn't want. So my primes, stupid thing. So my primes are this piece right here, and my not evens. So I'm going to highlight my not evens. So just like the one above it here. So my not evens is everything that's kind of outside. So this is my not evens area right here. Right, so if I were to highlight that, that would be the not evens. Right. So I'm going to do the same thing down here. So my not evens right here. So I'm going to highlight everything that's not even. All right. And you can see when I did this with my two highlighters here, I got a section between the two right here that are common, that are in common. So these numbers here are prime and they're not even. So I like this kind of word thinking that this is and. When you want to think of the word intersection, it's and. All right. So you can see it changed green. So that's what's in common between the two. So that's what the intersection is. What do they have in common? Those are prime and they're not even at the same time. So you notice that that 2 sits out there. That's not inside that little green area that we just created there. 1, 9, and 15 are not inside those common areas either. So I'm just worried about just the prime numbers that are not 2. So 3, 5, 7, 11, 13, 17, and 19. So those are my prime and not evens. Now you can do the same thing with the next one here. What's not prime? So not prime is all of this area. Everything outside the prime circle. That includes the part of the even circle there. And even. So I'm going to just highlight my even circle. You notice that what they have in common turned green there. So that's what we're looking for. So we're looking for, it's not a prime, and it's even at the same time. 2 is a prime, so I'm not going to include that. So I have 4, 6, 8, 10, 12, 14, 16, 18, and 20. There you go. So not including 2. Okay. Like I said, it's going to get a little bit trickier. So we're going to look at this next one here. I'm having problems with my kind of moving here. So let me just move this down a little bit. Okay. So maybe I want to figure out this one first. I want to figure out what are they talking about here? Prime, the union of prime and even. So this is just all the prime and even numbers. So I'm just going to highlight that area. Okay. So this is my union of prime and even numbers here. So the yellow, that's all the yellow piece right there. I'm just going to highlight that yellow. Okay. Now I want to determine what is not that. So not that is everything that's outside of this area. So what's not a prime and not an even at the same time? So if I just color that in, yeah. That's just a bad drawing, a bad color in there. So what that is, 1, what do we have? 1, 9, and 15. So what is not a prime and even? Not prime or even. I'm going to say this symbol, I usually say or. Remember, that's the union symbol. So prime or even, that's that yellow 2 circles there. And what's not this? So that's what that stands for. So again, I got this not here. So this next one here, I already kind of know what the intersection looks like. So that's that intersection piece. I'm going to highlight that. So that's the intersection between prime and even. So it's that piece there. Then I just want to know what is not that. So not that is everything that is around that here and all the way up to the universal set, all the way up to the edges here. So that's everything that's not prime and even at the same time. You notice that the only number that's in between the two here, that's in that yellow spot, is 2. Everything else, all the numbers from 1 to 20 that's not including 2, is in our set. So 1, 3, 4, 5, 6, 7. I'm just tired here. I'm just going to keep on going. 18, 19, and 20. So you know what's missing here? There's no 2 here in this spot right there. There's no 2. Because that number is prime and even at the same time, but I'm looking for what's not prime and what's not even. Yep, camera's messed up here a bit. Sorry. Okay. All right, so usually the type of questions you're going to get, like you'll get some of these Venn diagram kind of questions, and I see it later on here. I scroll here, there's some more Venn diagrams here. But the type of questions that you might get are going to be these ones that have numbers in them. Okay, so as I fill these out, like you're looking for some key words as you're filling out some of these Venn diagrams that have words. Like if you have the word only, that means it's usually, I have my 2 sets like this, math and art. So I have 2 sets, kids that are enrolled in both math and art at the same time. If I say only, it's going to be just in this piece here, so this little Pac-Man shape. So this Pac-Man shape, I'll just highlight that little Pac-Man shape here. This is the only math piece, right? On the other side, this is the only art, right? So if I said math and art at the same time, you can see your math and art. Or and, that's that piece that's in between. So this is the and section. So if I fill this out, the math only is this piece. So I put 28. So there's 28 things in there. I don't know what they are. Like I put down Peter, Ross, Mary, Jane, Ringo, Star. Did I say Bob already? Who knows? Michael. And I can put 28 kids in there. I don't know what 28 kids they are, but I know there's 28 of them in there. On this side over here, I have 33 kids, and I have 17 kids doing math and art at the same time. But I also have these 20 goats out here, these 20 kids that are doing nothing. So my universal set, if you remember before, my universal set is everything. So my universal set is everything in this box. That's the universal set. So my universal set is just going to be the addition of all these numbers here. You pull out your calculator, right? And you just go 28 plus 17 plus 33 plus 20, and you get 98. 98. So my answer for this one would be 98. Now this is a pretty easy question. There's no real, I could have just added the numbers up in that table up there. Over here, I could just added the numbers up in this table, and I could have got the answer 98 right away. Sometimes there's tricks. Sometimes they don't tell you how many kids there's only in math. Maybe they just tell you, okay, these are all the kids that are enrolled in math. So if I added some extra columns here just to fill in pieces, how many kids are actually taking math? Well, how many kids are actually taking math is the addition of these 2 spots, so 28 and 17. So 45 kids are actually taking math. How many kids are actually taking art? So I can add those 2 spots together and get 50 kids. 50 kids if I do that. So they could tell you that information instead, and they'll make the question a little bit harder to do. And you can see that there's going to be a question like that later on here, where they don't tell you that these 23 kids here only play volleyball and only play basketball, but they could play both at the same time. They tell us that 31 kids do not play either sport. So that's a nice number. I can put that 31 on the outside. Okay. So what I'm going to do is I'm just going to stop this video at this point, okay, just to keep these videos down a little bit, and then we'll continue the next one in the next video. So I'll see you then.